Okay, so this will be the second episode in a three-part mini-series about geometric objects and their explicit definitions. So we already created in the last episode, we created the base geometry called the geometric object. And we made it abstract and also created our abstract method called hit, which takes an array. Now there is one thing I didn't do. We're going to use this for now, but we will probably get rid of it later because our objects won't have colors, they will have materials. So we will just create a field called color so that we can assign a color to our object for now. So today what I'm going to be talking about is the plane class. So we're going to go ahead and create this in the package geometry, and we're just going to call it plane. Pretty simple. Let me make sure I line this up. Okay, so the way we mathematically define a plane is a 3D point in space as well as a normal vector. So we can create a plane based on this point subtracted from an arbitrary point selected on the plane, dotting it with a normal, and this equals 0. So I'll just write out what the normal mathematical function is for a plane. So your point subtracted from an arbitrary point, and we'll take this to be the dot product, dotted with a normal vector equals 0. So this gives us the definition for a plane. If you don't know this definition, it's more basic mathematics, so I would suggest that you read up on it, because we are going to be talking about some very complex, even the sphere is much more complex than the plane. So that's our basic mathematical expression. So, as always, what we need is a constructor. So we're going to create a constructor called plane, and it will take in a point and a normal. So this dot point equals new point 3D. Created that copy constructor, and we will pass in the point. This dot point, as well as this dot normal equals new normal, pass in our normal. We're also going to do one more thing. This dot color equals new color, and pass in the color. That's one thing I forgot. So for now, we will just, when we create our plane, we will create it with an arbitrary color. Why isn't it giving me... Oh, that's why. So extends geometric object. So we want this to be a derived class from the geometric object class. So now that we have our constructor, looks good, I think. This point equals new point 3D. Create the normal and the color. We can now create our hit method. So, as I defined it before, I'll write it again. This is the equation for our plane. What we can do is substitute in the equation for our array for that point, and when we solve this, we can find the value for which they intersect or they don't intersect. So substituting here, I'll just close this off. So substituting in the equation for the array, which is our origin plus the distance along the direction vector minus our arbitrary point dotted with the normal equals 0. So solving this, hold on, just give me a second. So we're going to want to solve this so that we isolate t by itself. So what we have is origin dotted with the normal plus td dotted with the normal minus a dotted with the normal equals 0. Maybe I'll space these out a little so that you can see it. So now what we want to do is take td dotted with the normal equals, what we can do is isolate. So normal dotted with o minus a equals 0. So that would be the same as the equation above that we just defined. So this would be o dot normal. Here, we'll do it on the other side. Then from there, we can move that to the other side. So this would be o minus a dotted with the normal and then we can finally divide this by everything else. So that's our final equation that we want. Seemed pretty simple, right? So let's see here. Let's see. Should be a minus o. Because when I moved it over, it's subtraction. So a minus o. So that's the final equation that we want. So what we need to do is create a variable. We'll call this t, double t, equals, so our point, our arbitrary point that we created on our plane. We'll do it point dot, and then we created the subtract method so that we can subtract another point. So this would be our ray dot origin. Then we want to dot that with the normal, and then divide that by our ray dot direction dotted with our normal. So that will give us the value for t. So now that we have that value, we need to, since we are using Java, if we were using C++, what we could do is pass in pointers for the t value. So what I did instead was if so I'll just place it here. If t is greater than, let's make it 10 to the negative 9th, return t. Else, return 0.0. So what this is saying is that if our t value is greater than some arbitrarily small value, and we create this so that we have proper lighting calculations and etc. It'll become clearer in the following episodes. But we do this for a purpose. So we return t if our t value is greater than this small value we've defined. Otherwise, we return the value 0. So in our loop, what we can do is say that if a value of t is not 0, that means it intersected that object. In this case, the plane. Otherwise, if the value is 0, it did not intersect any object. So let's just delete that now that we have this. And that is the sum total of the plane class. So we have our point and normal, which define our plane mathematically, as well as a constructor so that we can create a plane uniquely however we wish, as well as our overridden method from our base class geometric object, which takes an array and determines where that ray intersects our plane, if it does at all, and returns that value. So that'll be it for this episode. In the next episode, I'm going to cover the sphere, which will be, I think, much more complex.